Hello, welcome to our channel Parallax. My name is Pallavi, and today we are going to solve two questions of the physics theory paper, extended physics theory paper, IGCSE 0625, paper number 4. This is the specimen paper for the year 2023. The time for this paper is 1 hour 15 minutes. You are allowed a black or a blue pen to answer the questions and pencil for diagrams and graphs. We will be solving two questions in this video. The first two questions. So the first question is what you can see over here. There's a graph which is a speed time graph, and the question says to calculate the acceleration of the vehicle at time t, which is 30 seconds. Now I'm going to use red ink to explain the concepts, and blue or black ink will be for what you have to write in the paper, right? Okay. So let's talk about the acceleration. We all know that if we are given a speed time graph, then the gradient of the graph gives us the acceleration, right? Now the time over here required is 30 seconds. So at 30 seconds, what you are supposed to do is draw a line and mark the point and then draw a tangent to this curve. So draw a tangent to the curve and then find the slope or gradient of this tangent. So roughly this is what I'm getting, if you can observe this, right? And mark the slope. So we all know how to calculate the gradient or slope. It is the change in y over change in x, right? Which will be, if you look carefully at the, let me change the ink to blue so that this becomes clearer. So this is my 30. Change in y is from 30 to 5. So it will be 30 minus 5, and change in x is, let's see where we see the x-axis. It's approximately over here, which is roughly 72.5, we may say, 72.5 and 0, right? 72.5 minus 0. Let's check out what this comes out to be. So you're allowed a calculator in the exam, so you can use this. 30 minus 5 is 25, and you have 72.5 in the denominator. So you get roughly a 0.34 meter per second square. Let's check out the answer for this question as well. So this is the mark scheme. The mark scheme says the answer is valid if you get a range of answers from 0.30 to 0.45 meters per second square. So answer is correct. Well, let's move on to the next question now. Without further calculation, state how the acceleration at time t, which is 100 seconds, look at this, acceleration at this time compares to the acceleration at the time t, which is 10 seconds. So what does the question ask us to do? The question is asking us to see and compare the acceleration at these two time intervals. Let's have a look at the problem first. What's going on over here? So there's a vehicle which is accelerating from rest. As you can clearly see in the speed time graph over here, the speed of the vehicle is increasing, right? It starts from 0 and it is going up till 30. Then it starts decreasing over here, this part of the graph, right? Now, whether this increase is constant, it's not, right? Because the curve, the graph is a curved graph, right? It's not a straight line. Okay. So therefore, we know that the acceleration or the gradient is not constant. Now it's asked us to compare the accelerations at t is equal to 10. So again, draw a small tangent to see how this is. So, okay, this is how the tangent looks like. You can make it better by just making it a bit more at the same point. This looks better, isn't it? So it's kind of a steep curve over here. And you're asked to compare it with the value, same value at 100 seconds. So if you make a tangent at 100 seconds, this is the line which you get. Now have a look at the two lines. Clearly, line number 1 is much steeper than line number 2, isn't it? That means the gradient of line number 1 is greater than the gradient of line number 2. Or you can say that acceleration at 10 seconds is greater than the acceleration at 100 seconds, right? So therefore, how do you write down the answer? First, have a look at the number of points it carries. So it carries 2 points. So 2 solid points for these, right? You are supposed to explain why any change in acceleration occurs. So first you have to explain what exactly happens. You have to state the fact. So this is what you'll write. Acceleration at t is equal to 100 seconds is at a slower rate as compared to acceleration at t is equal to 10 seconds. You may explain the reason for this. That is from the graph, mathematical reason, okay? The mathematical reason is that the slope or gradient is less at t is equal to 100 seconds, which we saw, as compared to t is equal to 10 seconds. But this is not the explanation for the reason here, right? The question which has been asked. You have to give the reason, the physical reason why this gradient has decreased. So what will you say? That is your second mark. So 1 mark for writing down this. The second mark is to write down as the vehicle increases its speed. So clearly the vehicle was increasing the speed. If we have a look at the graph again, see, vehicle speed was increasing. The friction or the drag force. Now the friction or the drag force will be opposing it, or the air resistance will be opposing the motion of the vehicle. And this results in reducing the acceleration. So this is what you have to write for the second mark, right? And that's how this question is answered. Next, determine the distance traveled by the vehicle between t is equal to 120 seconds to t is equal to 160 seconds. Remember, this is a speed time graph, and we all know that the area under the speed time graph gives us the distance, right? So that means we are supposed to calculate this distance, right? This is the distance which we are supposed to calculate. Sorry, it won't be over here. Okay, now there are 2 ways to calculate this distance. First is you can find the area of the trapezium which is formed over here. Let's name it A, B, C, D. So area of the trapezium is given by this formula, half sum of the parallel sides, which will be BC plus AD, and multiplied with the height. Height in this case will be the height of the trapezium, which will be this. Look here, it's the distance between the 2 parallel lines. It's same always, right? So basically, it's the value DC. D to C. Okay, how do we calculate this? Half. Value of BC is what? It is 20 to 0, so it's 20. AD is what? 30 to 0, so it's 30. And DC is 120 to 160, which is 40. So 50 by 2 into 40, this is clearly 50 into 20,000 meters. And this is one way of figuring out the distance. Now you may not remember the formula for area of a trapezium. In that case, what you're supposed to do is, you still know that it is the area of this figure which you're supposed to find. So bifurcate this figure into a rectangle and a triangle. Now you all know how to find the area of a rectangle and triangle, right? Both. So use that. That will also work. Let's name this ABC and DE, right? So the rectangle BCDE will have the area length into width. Length is 20, width is 40. That's the area of the rectangle. Area of the triangle will be added to it, which is half times base, which is again 40. Base is BC. And height, in this case, it is 30 to 20, right? 10. So this is 10. So you get 5 into 40, which is 200, plus 20 into 40, which is 800. Therefore, 1000 meters. Again, the same answer for finding the area under the curve or for finding distance, right? So the answer over here would be 1000 meters. Any of the two methods are okay, you will get marks. Next, question number 2. Complete the definitions by giving the name of each quantity. So you're just supposed to write down the name of the quantity. Mass into acceleration is force. Force into time is impulse. A very, very important quantity. And sometimes I have felt that students find this understanding of impulse a bit difficult. So I'm going to elaborate a little bit on the concept before we move on with the B part of the question, right? However, if you just write force and impulse, you will be getting your 2 points over here. Okay, now let's talk about impulse. Impulse is also known as impact of force. Now, what does that mean and what are the formulae for it, right? Let's write down the formula first for impulse, all the possible formulae. So the first one which is given over here is force into time, which is impulse. Let's write it as I. Force we know is mass into acceleration. Mass into acceleration into time, therefore is impulse. Acceleration is what? Rate of change of velocity, where v is final velocity, u is initial. That's the change in velocity over time gives you the rate of change of velocity, and multiplied by time, which is this time over here, is impulse. The time and time gets cancelled, so we are left with mv minus mu is impulse. If you observe carefully, this is the rate, this is the change, not rate. Rate means it's always related to time. So this is the change in momentum. So impulse is also change in momentum. Now, what does this mean physically? So I'm going to give you an example over here. So we all know that we all have played on swings, right? Kids, they play on the swings. So if you have a kid who is playing and there is sand, and on the other hand, there's a kid who is playing on a swing, and let's say the swing is at a particular height, okay? And the floor is concrete floor, okay? And same height, let's say everything else is same. The kid is of same mass, everything else is same, except for the floor. Now, if a kid falls down, okay, on the sand floor, he gets less hurt as compared to a kid who falls down on a concrete floor. Agreed? Everybody knows this. Now, why does that happen? Let's observe why. See, the kid is having the same mass, right? And as he falls down, the initial velocity of the kid is also same when he falls, right? The final velocity in both cases will be, or the final momentum in both cases would be 0, because eventually the kid will come to a stop, right? So the V will come to a stop, therefore it will be 0. So the change in momentum or the impulse will be same. Then what changes? We know that impulse is force into time. Now, because there is a sand floor, the change of momentum from mu to mv takes more time in a sand floor because of the sand as compared to a change to the change over here in the concrete floor. Because it's concrete, so the change will be immediate, very less time. Therefore, if impulse has to be same, now let's observe the two cases, okay? Let's name this case 1 and this as case 2. So in case 1, impulse will be same in both. So in case 1, what happens? The force experienced by the kid will be much more or less, because we're talking about case 1. Sorry, that's the sand floor. So force experienced will be less as compared to the time, because time is more, right? Because it's taking more time to come down from mu to mv. On the other hand, in the second case, the force experienced by the kid or impact of force would be more because the time is less, so that the impulse remains same. I hope you got the concept here. But anyways, that's what impulse is. And these are the 3 formulae. So One is force into time. The other one is mv minus nu, which is change in momentum. However, we don't generally use the kg meter per second as the unit for impulse. We use Newton second because it's force into time. That's how it's defined. The SI unit is Newton second, and kg meter per second is used for momentum, right? And this is the second formula for impulse, force into time. Keeping all this in mind, let's move on to the next question. So it says that the man is using a golf club to hit a ball, as the diagram shows here. The ball has a mass of 0.046 kg. Golf club is in contact with ball for a duration of this much seconds, right? So the time is given to you, which is 5 into 10 to the power minus 4 seconds. And the ball leaves the golf club at a speed of 65 meter per second. So the ball hits the golf club and then leaves at this speed. Okay, this is a ball which is leaving the golf club after hitting it at a speed of 65 meters per second. Question is, calculate the momentum of the ball as it leaves the golf club. Now, what happens in such questions is students often get confused which formula to use because there's a mass given over here, there's a time given over here, and there's a speed given over here. So they randomly use, sometimes there may be random assessments in this, and you may get confused whether you should use the momentum formula, whether you should use the impulse formula in this case, right? So what to do in that? So try to understand what exactly is being asked. The question is, the ball is moving after hitting the golf club. The ball has a certain mass and certain velocity. And the question is very simple. You have to give the momentum of the ball. So you will not use the time factor over here, and you will simply do mass times velocity because that is what momentum is. Let's see if we get this value. So we take the mass of the ball, which is 0.046, and we multiply it with the velocity, which is 65 meters per second. So 2.99, or roughly 3 kg meter per second, because that's the unit for momentum, right? That is how you get the momentum. Okay. Let's see if the answer matches. So the momentum of, this is question number 2, and the momentum is 3 Newton second or 3 kg meter per second. Both the units are okay with, right? Okay. Calculate the average resultant force acting on the ball. Now, this is what I described in the situation which we talked about, the kid jumping from the swing into the sand floor and the concrete floor, right? So you have to calculate the average resultant force acting on the ball while it is in contact with the golf club. Now, here we need the time over here, right? So the momentum, or change in momentum, you may call it, that is mv minus nu, is 3, right? We got it in the previous part. So 3 is also called the impulse, right? An impulse is nothing but force into time. You have to calculate the average resultant force in this case when the time is given already. That means 3 is equal to force into 5 into 10 to the power minus 4. So F becomes 3 by 5 into 10 to the power minus 4, which is roughly 3 into 10 to the power 3 newtons, or 6 into 10 to the power 3 newtons, which is 6,000 newtons, right? That's how we calculate the average force. You can use your calculator if you want to. I did not use it over here. 3 and 5, it's just 60, right? 6, 5, 6 is 30. So that's how you get a 6,000 newtons, right? Okay, that was the second part of the question. Now we come to the last part of it. Question says, while the golf club is in contact with the ball becomes compressed and changes shape. The moment you read compressed and changes shape, in your mind, you should know that we are talking about elastic energy over here. And that's what the question also asks you. State the type of energy stored in the ball during its contact with the golf club. It is elastic energy. Okay, with that, we end the 2 questions of this paper. Hope you liked it. And if you liked it, please hit like and subscribe, and also share my video with your friends. Thank you so much.